Sample problem 8.4. Classify the following bonds as nonpolar, polar, or ionic. The bond in CLF, the bond in CSBr, and the carbon-carbon double bond in C2H4. Very simple. All you do is you look up the electronegativity values and look at the difference. So the electronegativity values will vary a little bit depending on where you look them up. Okay, now let's try the first one, CLF. Now, one thing I'm going to point out is that if you look at CLF, there are two elements that are in the same column. So fluorine is element number 9, and chlorine, actually let me make these boxes a little bigger so that I can fit in. The electronegativity values. The general rule is that within a column, as you go down the column, the value of electronegativity gets smaller. So it should decrease in this direction. And in fact, it does. Fluorine is 4.0 and chlorine is 3.0. Okay? So now you just look at the difference. The difference in electronegativity, take the larger one and subtract the smaller one so that you get a positive difference. It doesn't really matter. The difference is 1.0. That means there's a negative charge on the fluorine and a positive charge on the chlorine. We would say that fluorine is electronegative relative to chlorine, and that chlorine is electropositive relative to fluorine. Okay? Positive, negative. The general rule of thumb is if it's 0 to 0.4, it's covalent. It's purely covalent. If it's 0.5 up to 1.9, then it's polar covalent. And if it's 2.0 or greater, it's just ionic. Of course, we'll see in the lectures that this is not exactly true. That's a gross oversimplification, but it works for some of the problems. So since the difference here is 1.0, we know that this bond is polar covalent. Okay? Let's take a look at the second one. The second one is the bond between CS and Br. Well, cesium, you look that one up, it's 0.7, and bromine is 2.8. That's a pretty big difference. The difference is 2.8 minus 0.7, that's 2.1. Well, positive, negative, right? The negative goes on the more electronegative. This is ionic. It's greater than 2, so it's an ionic bond. Now, in fact, it's not 100% ionic, but we would classify that as an ionic bond. 2.0 or greater is ionic. Let's look at the last one, the carbon-carbon double bond in C2H4. I'm going to show you the entire Lewis structure. There you go, C2H4. Carbon-carbon double bond, that one right there. But the difference in electronegativity is 0 because they're both the same. The difference is 2.5 minus 2.5. That's 0. That means it's got to be a pure covalent. Okay? The electrons are shared. So we wouldn't even write any charges on them because it's a purely covalent bond.